시작했어?
응. 뭐 하려고?
링크 항상 다 똑같지 않아? 달라?
달라.
좋은 방법 있어. 그것도 있고 완전 많이 써놨다가 여기서부터 저렇게 하면 되지. 오른쪽 뭐야?
뭐? 아 이거 책 이름이야.
같이 않으니까 뭐 어쨌든 안 된다는 거야. 결론적으로. 뭐라? 결론적으로 안 되는 거야. 아 그래? 일단 저거 안 된다. 나 이거 뭔가 이걸 바꾸고 싶어 이거. 중국화. 뭔 비교? 아 배우가 너 도둑이야.
레이첼 언제 와?
몰라. 내 순간도 아니야.
오씨 나 나오잖아 왜?
지금 시작했어?
야, 강지 저번에 어제인가 강의 봤어. 저번에 강의 봤어?
왜?
레이저 얼굴에 계속 2021년에 뭐라고 어디? 정말?
그게 왜 또?
얼굴 들면 그거 해서 머리 핑계
화면 효과.
내가 그때 잘못 만졌나 봐.
아니 뭐 하는 건데?
아니 그뭐 2020 이렇게 왜 어떻게 나가? 다른 거 뭐야?
이게 뜨는데 왜 2021년?
구별 중에 2021고 있다고? 아니 다치는 거야?
그냥 무슨 살짝 그런 거 얼굴에 뭐 하는 거 있잖아.
나 해보 내가
나
해볼게.
나이도 다르면 이게 쓰시면 돼.
근데 라인이랑 탑이랑 다른 거.
아 이거 강진 이거 말이야 이거. 이게 잘못 눌렸나 봐 이게. 그래가지고 계속 막 들 때마다 이런 게 나왔어.
어떡해. 나 뭐한 거 필요 없애.
방송 나가고 있는 거 아니야 이거?
당연히 나도 이제 또 지워야지.
아니 저건 쌤 올 때까지만 냅둬.
아이고.
근데 언제쯤 돼?
아 이게 한두 번째 전. 17차인가 18차인가.
찾아봐야겠다.
이번에 다른 걸로 해봐. 그거 하지 말고.
지금 하고 있어 지금? 라이브 시작됐어?
너무 소리. 너 아까 모습도 라이브로 전 세계 생중.
뭐라고?
아니 근데 그 링크가 안 도는 사람들만 다르다.
야 뭐 배운 날이야?
얼굴 아닌데.
뭐 배운 날이야?
모르겠어. 지금 저번 거 틀어.
굳이 그걸 또 제목에 쓰려고?
눈 온다. 눈이 내려와.
아 뭐?
눈이 내려.
하늘에서
눈이 내려옵니다.
아야.
한번
진짜 됐어?
몰라.
라이브 쇼 브로드캐스트.
안 되는데?
아니 정면을 볼 때 되는 거 아니야?
정면 볼 때 나와.
그치 내가 이거 화면이 뿔게 보여 이러고.
이날 아닌가? 야 옷 뭐 입었었어? 아닌 거지?
아니.
하얀 옷 입었을 거야?
하얀 옷이 아닌데?
근데 머리 안 뜨는데?
자꾸
이날 맞아?
소ld 아웃.
진짜 TV 나오네? 어째서?
강준거 이리 와봐.
TV.
주문 폭주.
아 이게
오늘도
아 이거 2021 이게 뜻하고 2021 이게
스토어찜 하셨나요?
아 이거 아니야.
아 나와?
이거 지웠을 거 아니야 이미.
아니 안 지워서 채널은 있어.
띄어쓰기 하나.
붙여쓰기.
하트비.
이거 뭐야?
솔드 아웃.
야 이거 검색 필터 어떻게 하지? 검색 뭐 옛날 걸로 아 필터
이거,
삭제했으면
이거,
어차피 안 되나?
나올 수 없어. 하트 줄? 이거 아닌데.
아슴.
하트비.
얼굴 안 돼.
그 김건우가 폭로를 했잖아 그거를.
어떻게 하는지.
오늘의 혜택.
힌트잖아. 봐봐.
이게 뭐 얼굴 결혼놓고 한번 대답해볼까? 얼굴 그려놓고 그 위에 들지.
저 그림이 대체 뭘까?
소한테.
오 마이 갓.
기분이 뭐야?
아 근데 이거 우리
구력 사진.
빨리 보여줘.
주말 때. 아 근데.
아 얼굴 인식 안 돼.
원숙이 이제 안 된다고?
진짜 19는 절대 못 찾아. 2021년 찾아야 돼.
그게 왜?
안 돼.
얼굴 인식 안 되네.
엄마 한번 봐봐 이거 봐봐 그거 봐봐.
현실성
이제 저 위에 글자는 지우자.
이날 아닐 것 같은데.
리스키.
이날 아닌데.
레이첼 보기
뭐야?
나쁘겠는데?
오 진짜
이름이
맨날 찍었다.
오 어디?
썼어. 어떡해. 뭘 언제 만진 거야? 야 이거 이상한 거 같아. 다시. 뭐 아무것도 안 했겠지?
못 쓰잖아.
어떻게 한 거야 쟤는? 걔는 어떻게 한 거야?
또 뜨잖아. 2021 또 뜨잖아 2021. 야 레이첼 쓰니까 보이면 어떻게 돼?
이거 좀 화났. 와렸어.
끝났어 나온 거야? 아니 뭐 아니
끝났어.
나도 찾은 거 아니지? 어디 1층부터 쭉?
어 1층에 있었어.
진짜 되네?
아직 안 왔어. 중구야 저 레고인데 레고?
아 레고 아니 레고 강도잖아 이거 강도. 러버.
레고.
왜?
그렇지.
레지 또 뭐라?
근데
카톡 봤어?
봤어.
찾았어?
하자. 찾았어.
야 봐봐.
종아리. 그림 이건데.
종환기가 레고.
맞아. 맞아 이거.
야 봐봐 야 2021 봐봐.
종합이 아이디가 이거야?
어딨어?
잠깐 찾았어.
악티비.
봐봐.
아 맞아 이거.
진짜 나오네.
나 안 눌렀는데 이거.
아니 근데 지금도 나와.
네?
지금도 광고가?
어떡해.
제가 눌렀어요.
잠깐만 봐봐봐.
진짜 들어볼게 한번.
뭐 보는데?
막 계속 무슨
아까 전에 오늘의 혜택 오늘의 혜택 나왔어.
주문
아니
폭주.
이거 올려줘야지.
아니 또 네가 또 레이첼 왔다고 또
야, 아니
봐봐.
뭐 하는 거야?
아니 여기를 골라야 된다고 여기를.
근데 레이첼 한국 할 수 있어?
이게 안 나온다고.
근데 이거 이런 것도 말할 수 있어?
번역 잘하고.
아니 뭐 광고가 계속 나오더라고 아까 말했더니. 주문 방금 지나갔지? 못 봤지?
근데 교통이 엄청 막힌다고.
아니라고 뭘 앞으로 가냐 갈 데가 어디냐고.
앞으로 가야 되는 거 아니야? 앞으로 가는 거?
앞으로 가면 오늘의 혜택 나오잖아.
뭐 하는 거야?
그때
지금 나와요 이제. 지금 바로 주문하세요 나와.
왜 지금 계속 뭐지? 지금 안 나와.
그 앞으로 돌려주면 안 돼.
아,
그거
사천
지금
원
나올 수 있는데 잘못하면.
돌려주지 않아.
뭐라고?
돌려주는 거라고. 엄마
그렇지
지금
않아.
모르는 거야? 되잖아. 아이고 이거 모르네.
좀나 나오는 거.
지우개 왜 갖고 오는 거야?
이거 조금 더 봐야 돼 이거. 조금씩 이거 안 나와.
아 미쳤어. 아 그만해.
저 그림
아이,
그리지 않아?
아니 그림 앞에 그림.
이거 그럼 레이첼 오면 내려올 거야?
아니 그 전에 이거 눈 전에.
그 전에 막 주문 폭주 막뭐 이런 거 계속.
그런 거 말고.
눈치가 더 나왔다고?
오.
양원 나왔네 양원.
여기 봐봐 여기 잘.
2021.
2020.
그
진짜 나왔네.
그게 나오면 안 사라지네.
오 뭐야 이것도 떴어 이것도. 파티.
화장 계속 뜨더라니까.
야 저때까지 진짜 쓰고 있어 미쳤어.
주특가요.
엄마 링크 올려달라고 링크.
야 저런 거 계속 뜨는데 올려도 돼?
이거 진짜 이렇게 해도 되는 거예요?
이제 없어져?
안 없어질 것 같아.
한 개만 누르자 이거.
아, 이거
좋겠다.
조금 느리네.
마지막에.
네가 여기 있어. 쟤 쓰고 있어. 여기서 좀 쓰고 있어.
초특가 5개 세트 첫.
아 근데 그거 눌렀을 때만 딱
다
뜨는
끝났지?
건가?
지나갔어. 떴는데.
강준이 여기 와서 노트북 그러다 다 쓸어줘야 다 쓸어.
이렇게 할까?
야, 곧 나온다.
여기다 놔둬야지 지금.
아직 안
조뜨까리.
여기서 해 위험해.
조뜨까리. 내가 멈췄어 이거.
그만 눌러라.
그만 눌러라 정말.
야, 이거 또 손 나왔다. 봐봐. 이렇게
그만
봐봐.
눌러야지.
맞아,
뭐
맞아.
하는 거야?
제일 많이 눌러놓고 지금.
제일 많이 눌러놓고.
조뜨까리 이러고 예.
주막 핸드폰도 열이.
근데 왜 안 오시냐 리스?
능청이 막힌데. 차가 엄청 막힌데.
김은혜도 안 오고 있어.
얘는
교통이 막히고.
근데 안 와요.
오늘 보다 걔
코로나 걸렸어.
코로나 걸렸다고?
아니야. 주희 누나 학원에 있어서 석진자가 주희 누나 학원에 있어서 그래서 오늘 은혜도 그냥 같이 쉬는 거야.
처음에 주인호야 또뭐 검사 받잖아.
아이고 좀 문제가 많다.
학원에는 괜찮아.
가까이 좀 빼서 이따 갈 거야? 아니 걸려 드링크.
뭐가?
진짜 내 차를 제 집에 나. 그게 저번 거죠, 저번 거?
저번에도 머리에 뭐 왕관 나오던데 막.
그러니까 저만 거예요.
이게 뭐였는데?
안 돼.
아왜 안 돼?
영감 찍을 거 없어.
무슨 목사님 방 가서 스스로 나와.
먹어.
그거 들어도 목소리 많이 계속 듣던데 맞아. 아무거나 잘못 먹으면 목소리 막 두드려 맞아 두드려.
내가 먹어. 이름 썼어? 안 썼네.
강부사님 언제 오신대?
이거 없네.
뭘로?
강부사님 안 오시나?
강정구.
이거 띵크와이즈 2020 뭐야?
아 어떻게 알았어? 아 이거
PPT 같은 거야?
학교에서 뭐 하라고 했거든? 프로그램인데
프로 PPT 같은 거.
PPT 안 하니까요.
좌우명.
이런 거 해서
미용실을 안 갔다 왔는데. 저번에 엄마 지금 성공했어.
뭐야 이거?
뭔가 그냥
이거 수사 같은 거구나.
맞아. 그냥 뭐 이렇게 막
기기는 왜 쓰는 거야?
뭐 기기 좋아하잖아. 아 그러니까 그때 그 강도사님이
이게
하라고
뭐야,
하는
이게?
방법 그거.
그 너희
아니 나
창문
이거
그
했어.
창문 거기 사는 거야?
맞아. 보이고 뭐 이런 식으로 그냥 계속 하는 거지.
오.
무슨 이상한 애지.
그걸 돈 소상도 막 갚아.
돈안 주지 당연히.
세상에 이렇게 돼?
네.
신기하다.
진짜?
다반 거야?
엄청 작네 근데.
이거 학교에서 하는
몇
거.
개는 오시네.
야너
그때는 작아?
아 이거 보이보이도 제일 많이 들어.
우리반도 그래 시끄러워.
쓸데없는.
너네가 시끄러워.
형 영화도 하잖아.
우리 반? 아니 카톡에서.
우리 반 엄청 시끄러운데. 우리 반에 좀 아픈 애가 있어서 막
조금 정신 상태가 약간
야 대체 뭐야?
좀 활발한 사람.
야,
아
야,
누가 그랬어?
우리 반 애들.
난 우리 반
귀엽고
국분이
내가
뭐야?
이 녀석이
아 진짜 우리도 같은 교환을 그랬다니까 뭐냐고?
진짜?
어 아니 안 했어. 근데 무슨
간다.
자.
어떻게 생겼어?
아니 그 무야와 무한도전.
우리 반에도 이지민 있는데.
무한도전에서 나온 거야.
우리 학교에 이민채 있어.
나 할아버지 원래 무한도전인데 그 알아 몰라 무야로 막 해가지고.
맞아.
애들 어떻게 생겼어?
애들?
어.
너 학교 이름 뭐야?
상분여고.
누가 청소년으로 여자친구 있잖아. 너 사람 있으니까.
너는 뭐 아무 말도 안
연락하고
했어?
있는 사람이 뭐 있든.
누군데 누구?
아니
이름이
근데 사귀었는지 모르겠어. 근데 물실을 맨날 받아.
이름이 누구야?
몰라 이거.
아니 내 친구 중에서 한 명이 보인 거를 갖다 냈어. 그래서
얘 한번 보여줘봐.
근데 이거 생긴 거는 너무
빡빡이 아니야? 이게 빡빡이 아니야?
아니 나 그래서 세븐틴인가 보지.
어, 빡빡인 줄 알았는데.
근데 생각
누가
이렇게
이거?
안 생겼어 미안한데 다 그렇게 안 생겼어 당연히.
다 조작이야.
이거
누가 이러는데?
너 좀 그렇다 이 사람 부담스럽게. 오 갤럭시 애들 좋은 거 쓰네 핸드폰.
아니 핸드폰 보라니.
무료.
어쨌든 너가 생각과 많이 다르게 생겼어 얘가.
무료.
아니 애들이 그래서 그 폰을 하다니 갑자기 무료로
무료하네.
하는 거야.
우리 무약을 3연시켰어.
아 진짜? 우리 끝났어. 그냥 무슨 이상한 걸로.
그폰 너네가 정하는 거야?
어
중학교는 마음대로 지내줬는데.
맞아.
우리 그폰은 몰랐어.
왜 무약을 뭐야?
아니 하는 걸로.
아니 애들이 막 새벽 축구 보고 막 졸리다고 맨날 수업 시간 때 뭐라 해. 나 새벽 축구 때 언제 첼시하고
어디
엘버튼하고 해가지고 애들이 첼시가 2대0으로 이겨서 내가 조크만 해줬다가 좋지 너무 좋아 이래가지고 사실 내가 누가 이겼어도 좋다고 하려고 했다고 하니까 막 웃더라고. 그리고 내가 어제 그 회장이 어제 과제를 한 번에 싹 정리를 해줘서 너무 좋았어. 나 비상소가 안 나왔거든.
아 나도 안 나갔는데.
너 추천됐어?
어.
그래서 됐어?
어.
진짜?
누구한테 됐어?
너가 누구한테 추천됐어?
아니 나 모르는 애한테.
모르는 애한테 너가 추천을 했어.
모르는 애한테 갑자기.
적당히 생겼으니까 너도 부려먹으려고 하는 거 아니야? 아니,
몰라 그런가.
나도
근데 회장은 아니거든.
부회장이야.
야 상준이가 종료시켜. 너무 앞에.
학교 총무부는 뭐 하는데요?
광고가 너무 많이
어?
학교 총무부는 뭐 하는데요?
아니 근데 이걸 처음부터 하지 말았어야지.
예상까지야. 뭐.
ARTGF?
그거만 해?
뭐...
야 학교 총무부야.
뭐.
뭐 없네.
아 이거 R에서 하는 거야. RPDF.
아
이거.
그래 뭐야? 뭐 하는 거? 아야 뭐해 이상한 거 하지 마. 이거 뭐야?
그럼 이거 뭐야?
몰라 이상한 거.
뭐 나왔어?
몰라,
야
이거
캡처 어떻게 해?
저?
여기서.
뭐야? 그럼?
이렇게.
뭐야? 신기하다. 근데 그냥 이거 누르면 되는 거지.
그러니까
뭐지?
마우스가 안 될 때 편하다.
넌 크롬 안 써?
나 그럼 써 EBS 때문에.
응? EBS 거기.
EBS 왜 이래서도 되는데?
아나 두 번 계속 끊기던데?
너 EBS야? 줌 아니야? 사프럼도.
주면서도 하고 EBS 해도 돼.
아 뭐야 그러면은
우리도 EBS인데.
뭐 엄청 많이 바뀌었네 근데 온라인 클래스.
완전 바뀌었어 예전에. 초록색이던데?
응?
보라색 말고. 보여줄까?
일본은 뭐 하나 알려주면 알지.
네, 알려줬어야지.
열심히 치길래 계속 이렇게 집중하는 사람은.
여기 어디요?
좀
나는 가져가.
왜?
가져가자.
왜 이렇게 덥냐 여기?
많아.
나가지구나.
이거 알아?
응?
이거 알아?
야 근데 이거 어떻게 하냐? 막 여기 옆에 막 글씨 엄청 많이 나오는 그런 게 있잖아. 그거 어떻게 하냐?
이상한
뭐야 이거
거.
CCMD 그거야?
야,
뭐 하는 거야?
야,
뭐 하는 거야 이거?
뭐 하는 거야?
이거 어떻게 하는 거야? 나도
뭐 하는 거야?
해킹 뭐,
해킹 아니에요? 해킹 아니에요?
뭐 하는 거야
해킹
이거?
아니야 저게?
해킹 아니야?
아 뭐냐 이거 뭐야?
이
근데
컴퓨터.
왜 다 25% 이런 거까지밖에 안 들었죠?
아 왜냐면 이거 다 한 번에 쫙 떠올리는 거죠.
이거 왜 해킹 아니야 이거?
어떻게 하는 거야? 뭐 하는
이거
거야?
명령어 치면 그냥 돼. 명령어 같은 거.
엄마가 올렸어요.
맞다.
윈도우 그.
알로.
어떡해 hello.
누군지 알아요. 누군지 알아요.
Teacher, did you solve the question?
아니 안 봤어요. 너무 빠빠서. I'm sorry.
I'll give you an answer.
No, I don't have time to solve it yesterday.
야 이은지 어떡할 거야 이거?
Then the next Friday.
Yeah, I had to write a whole.
이거 뭐예요?
Big pen brand. Big ball pen.
Thank you. This is different in actual bag.
어.
달라요.
Pronunciation.
달라요.
음.
여기요. Bag.
Bag.
네.
Bag.
Bag.
네.
Bag.
원스톱. 백. Front and back.
Bag.
백.
Bag. 달라요. Bag.
Shellfish is so You tennis? Where is tennis
I
racket?
went home to eat, and then that's why I was late, because I was hungry.
You like Korean food?
Yeah,
What Korean food?
everything.
음.
Except
청-
samnakji.
어.
I don't like samnakji.
청국장.
Probably you ate it and like it.
오. 와우.
중장해서 smell.
weird smell 된장찌개.
I like that. Yeah.
와우.
it is 된장찌개 for the advanced people in Korea.
I had homo.
응?
홍어 really?
호호.
I know.
홍어. 홍어.
와.
Really?
Oh.
오. Then you might eat 산낙지.
I know homo is like. I don't hate it. It's not that like I can eat it, but I don't like it. It's just
아니야.
cold. Like your nose. Is,
You like 비빔밥 or 불고기 or 홍시 뭐 있어?
kimchi.
오 김치. She can't eat kimchi.
Really?
Because she is very poor of eating spicy foods.
Oh yeah, she doesn't like spicy food. Yeah.
Yes.
Bijection.
Bijection. Bi means two. Okay. So this is very important. You need to know what this thing is. Okay. So for every A in A, remember?
If and only if.
So the if and only if, what that means is, it means that if this, like, so if A is, okay, if and only if, it's like this. It means that the proof, it goes both ways. It means that if A then B, if B then, and if B then A. So it means like, if I like kimchi, I like Korean food. That's, okay? It's like, if I like kimchi, I like Korean food. And then it's, you say, if I like Korean food, I like kimchi. It'd be, both need to be true. That's if and only if. Okay? Okay, hold on. So, for every A in A, f of A in B, and for, and how do I explain this? It's like a one-to-one matching. So it means that f of A is in B, and for every f of B in B, B is in A, right? Okay, I'm gonna draw a picture and you're gonna get it. Alright, so here's A, right? Alright, let's have it be A, B, C, D, right?
Yes.
And here's F of A, F of B, F of C, F of D. It's like you can draw a one-to-one. It means it's exactly the opposite. Now, there's no bijection. If I put some point here, F of E, no bijection. Okay? So it's like you have two sides and you perfectly match them up. You know, it's like a one-to-one matching, right? So, it's like, it needs to go, each thing in A matches to exactly one thing in B. I mean, it could be like, you know, this goes to this, and this goes to this. Right? And this is A, B. Okay? So, the thing where this comes in handy actually is it's a little bit abstract, but you can form if you can form a bijection between two problems, then you show they're the same problem. So it's like, if I give you problem A, okay? I ask you a question. If you can show that everything in A, so like any kind of, I can transform, say like C is a case of problem A, right? Then I can say, if I can show that f of C is in B, then I can form a bijection and I show that, you know, C in A, and that there's no other value in B. If I can show like that they all map perfectly to each other, then you can find a bijection, and what that means is that solving B is the same as solving A. Okay. Okay, so basically what this is it says I give you one problem and you tell me it's exactly the same as solving this other problem, and here's why. So it would be like if I said, okay, let's give you two problems as an example. Alright.
Why we write A and F of A?
Because in B it could be a different description, right? B is a different problem.
Yeah.
So it's like if you had like f of A is like part of B, and then A is part of A. B, you can transform it, right? Okay? I'll give you an example. Okay, so you know coin flips, right?
Yeah.
So in coin flips, you know, you have like heads or tails. There's two sides to the coin, right? So, if I asked you, you flip a coin, let A be, you flip a coin 3 times. Right? How many, like, I asked you, probability of 3 heads. Okay? That's like 3, it's the same 3 times, right? 3 times. Alright, and then let B be, I have, you know, 2 markers in the box. I choose, so B is 2 markers of different color. Alright, and then you have, say, it would be, the hard thing is that you'd have to be, okay. And then you have 3 people pick one of the 2 markers. So it's like you've got, you know, blue, 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 and then red, 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 and then person 1 comes and they pick one, person 2 comes, they pick one. And then it would like be asking the probability.
Why is to one of what?
One of the two.
또
Okay. So I'm claiming that these are the same problem. So how can we make a bijection? So let's let A be first coin toss heads. Right?
Okay.
And then F of A, what's F of A? Sorry.
First person make a
Yeah.
choose a different color.
First marker blue. Right? And then what is B? B equals second coin heads. F of B equals second marker blue. Right? And then what's what's C?
First coin toss head.
Yeah. Third blue, right? Okay. So the idea is that every possible event in this one maps to an equal event in the other one. Right? So okay, here, let me draw this. It's like, okay. So it's like we have A is the first coin toss is heads, right? 1 heads. Okay? Let that be here. This is 1 blue. Okay? 1 blue. Okay. I'm claiming that these are the same.
The
What?
probability.
Well, I'm claiming that in my mapping of problem A to problem B, this corresponds to this. Okay? And then I'm saying that the second heads corresponds to the second blue. Right? And then I'm saying that third heads corresponds to the third blue. Right? And why are these the same?
Because the probability is same.
Yeah. And then, so actually what I should really do is I should also add these other events, which is 1 tails, 2 tails, which is the other side of the coin, right? The other option. 3 tails, and then 1 red, 2 red, 3 red, right? Because these events can also happen, right?
Yes.
Yes.
Alright. So,
Why there are 6 situations?
because there's 6 different things that can happen, right? If I flip a coin 3 times, right?
Yeah.
Well, the first one can either be heads or tails, right?
Yeah.
The second one can be heads or tails.
Yeah.
The third one can be heads or tails.
Yeah.
So I have to write out every possible, case, right? And then what? Like the first person could pick red or blue, the second person can pick red or blue, and the third person can pick red or blue. Okay? Alright. So this means that for everything in A maps to vice versa. So do you know what vice versa means? This is important, you need to know what this means. Okay. So vice versa means like everything, if I say everything in A maps to something in B, it would be like if we swapped these two. So it would be like B, everything in B maps to same thing, something. In A, right? So vice versa, it means like you swap the two things. So, it would be like, okay. You could say a correct statement would be like 1 divides 3. Wait, hold on, no, I have to think of something. Okay. Okay, say x equals y. Okay? X divides y and vice versa. Why does that work?
Y divide X.
Yeah. Vice versa means y divides x, right? Because it's like swapping these two things. And that's true because x equals y. Okay. So this is just, I just want you to know what this thing is, because it's very important, and a lot of times when you encounter sort of difficult problems that might seem difficult, there is some sort of bijection that you can make. So if you can say, oh, everything in this problem maps to exactly one case in this other problem. But say like, I know how to do problem B. I don't know how to do problem A. What if I can show that problem A is the same as problem B? That's really nice, right? Because then I don't even have to solve A. I just solve B, and that solves A for me.
But don't you have to prove that A related to B?
That's the hard part. So generally, a lot of problems that you'll solve in math, it's gonna, like, you're gonna have to spend most of the time proving that it's the same as something else. Okay?
Then why we have to do that, because it's hard to prove that it's related?
Because sometimes it's very difficult to solve a problem unless you can prove that it's the same as a different problem that you know how to do, or you know is really hard. So in a lot of like computer science, what you'll get is like, you'll get a problem that seems hard. And if you can show that problem is the same as an impossible problem, then you're good. Because you know you can't do it then. Okay? So it's kind of a difficult concept, but it's just something I want you guys to start thinking about, because it comes up a lot.
So there is some situation that you have to prove that is the A and B same problem, because solving A and B is difficult.
Yeah. Hold on. I'm trying to find. Give me a sec. I found an easy example of this. We'll see if it's possible. Okay. Okay. Yeah. So. Hold on, let's see. Alright. So here's a good one. So, remember the problem that we did yesterday with the subsets, right? So that can actually be explained and proved using a bijection. Okay? So the problem we had yesterday was let S equal 1, 2, up to n. We did 100, right? But it's n. Okay. Alright, so I asked you for the number of subsets of S. What is that?
2 to the n.
Yeah. And we said it's 2 to the n. Why? Because either any entry can be either be in or out. Now, here's where the bijection comes in. If A in S is in, let A equal 1. If not, A equals 0. So, here's my problem B. What is the number of length n sequences composed of zeros and ones? So start thinking about why this is how does this relate to the bijection thing? So what's the answer to this question?
What means A 무슨 S?
So it's an element. So A is some number. A could equal 1. It could be 2.
It could be minus 1.
Could be n. No, it has to be in S.
Uh,
And S goes from 1 to n. Okay?
Okay.
Alright. So we know the answer to this because we figured this out. Now I'm saying, if A is in the subset, so in S prime, you know, right? Because we said for each element in S, it can be in or it can be out. I'm saying in equals 1, out equals 0.
yeah.
Alright. Now what's B?
What is B?
B, I asked you, what is the number of length n sequences? So I have n, digits in the sequence composed of zeros and ones. So anything, say I could have, n ones, where this is n, right? Or I-
Everything in? Everything in?
Yeah, exactly. That's the point. This is going to demonstrate exactly what the bijection is. So, what is the answer to this question first?
What's the length?
N. The length has to be n. Okay, it could be n zeros.
줄 길이가 어디서?
It means there's n zeros, n of them. So 1, 2, 3, 4, 5, 6, 7, 8, n. Okay? It could be, but you could have, like 1, 0, 1, 0, 1, 0, something like that, But it still has to be n.
Okay.
So tell me the answer to this question. 아니, 그거
So the number of the
n개 있어요. 그냥 you have either 0 or 1. Okay? How many n length? The length is n. So you have 1, 2. You have n items,
Yes.
and each can either be 1 or 0. Okay?
So only two options.
Only 2 options for each one. Okay. So it's like if n equals 3.
Yeah.
Alright? What do I have? I have 1, 1, 1. 1, 1, 0, 1, 0, and then
0, 0, 1.
0, 0, 1,
1 0 0
1, 0, 0,
0 0 0.
0, 0, 0.
아.
Eight situation.
Okay.
So we have to find out the formula.
Yeah, I want you to tell me the answer to this question.
Oh.
어.
Oh, you can do it, okay? You have n of these. For each one is 2 options, 1 or 0. How many? Total.
8.
Yeah. What about for n?
2 to the end.
2 to the end?
Yes. Why?
There's only 2 situations, there is n number.
Yeah, 2 options, right? 0 or 1. So the first one, 0 or 1. Times, second one, 0 or 1. Times, third one, 0 or 1. And then the nth one,
0.
and
There's
there's
n.
n, and that equals 2 to the n. Okay. Interesting. I'm claiming you can form a bijection from this problem to this problem. And I gave you the answer, basically. I gave you the answer. This is exactly what a bijection is. So I'm saying that you can say that these two are the same problem. Okay?
I don't know what's the second question means.
Ah. So the second question is saying I have n things.
Yeah.
Each can be 0 or 1.
Yeah.
How many sequences can I make? Right? So it's like I could have n ones or n zeros. Anything, any of the n can be 0 or 1. Okay? It's like this. This is n equals 3. So you have everything has 2 options. Right? Now, I asked you, you want how many subsets? It has n numbers. Each number can be in or out. How are these related? Why are these? I'm claiming that they're the same problem and you can make a bijection. And I want you to think about it for a sec, because it is kind of hard conceptually.
이게 그 0이나 1이 0이나 1로 그러니까 n개의 숫자가 있을 때 0이나 1로 만들 수 있는 조합의 전체 수를 구하는 거지. 저 했던 것처럼. 그러니까 바이젝션을 하라고 했는데
I don't know what relation with that and that.
That's what I want you to find. I want you to think about how these relate. How did you solve this question?
I don't understand what first problem was.
Yes, we solved it yesterday.
저뭔 뜻인데?
The number of subsets.
서브세트의
만들 수 있는 집합의 개수.
It's like
아,
subset can be like it could be like 1 or 2.
yeah.
Size 1, any size. And so how many subsets are there? Each number can be either in the subset or out of the subset.
It's the same answer. It's probably.
Yes, why though? That's why I want you to see the relation.
in or not,
In or not?
0 or 1.
Yes, I wrote the answer for you.
So there is not the proof.
Well, why? Can you explain it further to me?
Oh, I explained you 0 and 1, 0 0 or 0 or 1.
Why is that the same as this? Exactly why? You gotta prove it, not proof by I think it's right.
Vice versa.
Proof not proof by I think it's right, proof by it is the same thing because valid reason. I think he gets it, he just doesn't know how to express it. He understands. Explain to me. I think you know. I think you understand. It's okay if you're wrong. No one else got it. Yeah. Yeah, yeah. Yeah. And that one is also 0 or 1, right? The nth one. Yeah. Yeah. So what's our rejection? How do you make a matching graph? How do you now you wrote the answer. Now I want you to draw the connection. So yeah.
1H 1D 그
Yeah. Yes. Okay.
I don't know how to prove.
It's just explain to me why it's the same. Okay. Alright, so here's our S, right? We have 1, 2, 3, all the way to n, right? Okay? Each one can be in or it's easier to write in or out, right?
Yes.
In or out. In or out. In or out. Now, what's problem B? We have n items, right? So we have 1, 2, let's label the numbers. N minus 1, n.
List 1 or 0.
1 or 0. 1 or 0. 1 or 0. 1 or 0. 1 or 0.
Same.
So, what does in equal? In goes to 1. And 1 goes to?
0.
1 goes to in.
Yes.
Out. Out goes to?
0. Out.
Yes.
so
Bijection. 2 options. Everything matches up, right? The numbers are correct. This can't match to anything else because there's n items in each one. So each has n items. And everything in one maps to exactly one thing in the other. So everything in S maps to item in B and English and
Only?
swap S
Vice
and B.
versa.
Yes. Important. And vice versa.
Vice versa mean can swap.
You can swap these two. Everything in S maps to an item in B, and everything in B maps to an item in S.
Hooray.
Alright, so there's the same problem. That means that if you solve one, you solve the other problem. So you can ignore this. This goes away. Bye. And then you just do this, which is easily 2 to the n because there's 2 options for each one. Okay? That is a first example. Let's do one more example.
This is not the main question.
No. There will be more main questions. I want to just go over this first because we did this problem yesterday, and I think that it's a nice way to introduce the bijection. But I found another one that's like also pretty easy. It's actually
뭐야? 질문 안 하고?
은혜가.
질문?
어?
Yes.
and she says, I don't understand
What?
almost whole thing.
Okay, what don't they understand? Explain. Do they not know the answer to this question?
Yes.
안 되나 이거 저도 아닌데.
몰라.
What should I go back to?
아니, she asked what
은혜 said she gave up.
No! Don't give up! Never give up! Don't give up!
she gave up.
No. We explain. I want you guys to explain it to her now.
What?
Yeah. I want you to try to explain it. That's better training. Then you learn it better.
Woman, you explain.
Yes.
와우.
Yeah, you solved it. You should
Yes,
explain.
you solved it.
앞에 나와 설명해줘 여기서.
Yes.
Come on.
In English.
Yes.
Try.
English is fun.
And explain to her.
Explain. He did. He knew what was going on.
Yeah.
He knows what's going on. I want him to teach it.
Yeah.
He has to teach.
Professor Son.
Yes.
I want you to explain it.
I think you can.
You can do
Professor
it.
Son.
Have
Yeah.
confidence. Ah.
Okay.
Am I too scary? Men, they tell me I'm scary.
Applause. Professor Son.
Yay! Okay.
처음부터 모를 때. 처음부터.
어디서부터?
At first.
At first? 바이섹션부터? 어디서?
Yes.
어.
Summarize that.
For example, I think.
So what is the why? What are both the problems? Say what is this problem? What is this problem? And why they are related.
오케이. 어. 개인적으로 설명하는 거 아니면 뭐?
Hold.
아니 그게 아니고 한 명한테만 하는 거냐고.
아니
다 알아듣겠지
아,
그러면.
I think you couldn't understand. I understood, so I will give you.
하지마.
Arrogance.
하지마.
Yes.
그냥
오케이. 빠르게 본론부터. This means the number.
색깔 바꿔줘.
Letter big.
뭐 까먹어 진짜.
Big letter. Right, big.
Red color.
오케이.
Number.
핸드라인 엄청 좋아.
Subset.
그 미국 여자보다 좋아.
Really?
와우.
미국 여자 그렇게
오.
잘 알아.
Okay.
그 너무 잘 너무 예쁘게.
The subset means that S is the set of holding 1, 2, 3, ...
Yes, S includes that.
So subset is included in this set. So subsets if we call this M can be 1 and 2, 5, 7 because M is included in the set because it is the subset of S. So
Everything in M,
yeah.
in any M, is in S.
Yes.
Wait.
Yes.
Then we have to know we have to find the number of the subsets. Since we had think each number individually.
Yes, so the number of subsets, it could have one element, it could have 0, right?
Yes.
It could have any number between 1 and n, right?
Yes. So let's think about the number 1. as I say, the subset of S can include one or not, because it is a subset of S, and 2 is also what?
아니. So it's just because not because it's a subset, because it can have any of the elements that are in S. It can have 1, or it can have 2, or 3, or 4, or both, or all. What? What are these doing? Are they making fun of him? If they're being mean, I'm gonna kill them. Good job. Yes, so 1 can be in or out.
So the 1 can be in or out
Of subset.
of subset, and 2 is also in or out. 3 is also in or out. So 1 can be in or not. So 1 has 2 probability, and 2 is also
2 options.
2 options, and 2 has also 2 options, and 3 has also 2 options. So n also has n minus 요건 지우는 게 낫겠고. So n also has 2 options, but so you may think you can we have to multiply this because the subset of S can include 1 number or 2 numbers or 3 numbers. So if we multiply all of this,
Wait, why times the?
Hmm?
Please explain again.
Why times?
Yes.
Because it can have 1 but not 2. Or not 1 but 2. Or 1 and 2. Or neither 1 or 2. So it's 4 options for 2 elements, right? Because each one has 2 options. Each one has 2 options,
Yes.
2 options, 2 options, 2 options. So it's counting the 2's multiplied.
She asked, in S, a subset S has no numbers and no
Yes,
number.
no numbers is
Yeah.
okay. Empty because it can have not 1, not 2,
It's like
not 3, not 4. Yes, it's the empty, nothing.
So assume that this means keep going. This is maybe this 1, 2, 3, and and n. So we have to multiply 2 to the n times. So we have to so this means 2 to the n. This is the number of subsets of S. Okay.
왜 아니 하지 마.
아니 다 지워야 되겠나?
Leave it.
깜짝
They can see.
이거 좀 지워졌는데 이거.
아 괜찮아요. 그냥 숨으면.
네, 설명을 하는 거.
You
저
can do it.
기억 못하겠는데.
You can do it.
깜짝 펜을 써줘.
It's n. You have n 1 or 0.
오케이. So 깜짝 패드로 써달라고요? 알겠어. So this program asks us to solve the if this set has n numbers of elements, and it has to be 1 or 0
It's a sequence.
sequence.
Sequence because it's a list. It's not a set. It's just numbers, right?
Sequence. Okay.
Sequence.
So this sequence has n elements, and each element is 1 or 2. So 1 or 0. I'm nervous. So
It's okay.
okay,
Don't
so
be nervous.
let's think about the options. This is if one first, second, third, then and okay, then this can be 1 or 0, 1 or 0, because all the elements have to be 1 or 0. This is also 1 or 0. This is also 1 or 0. Oh, then we can find that 1 or 0. So it has 2 options and also 2 options. Also 2 options and 2 options. And 저는 그랬듯이 we have to multiply all the things. So we have to multiply 2 to the n times. So this is also 2 to the n.
Yes.
So
Now comes the hard part.
okay.
How is this related? Why are they the same? The same problem.
Erase and explain again.
No, you can try to explain. This is harder though.
I think I have no space.
It's okay, don't worry.
She said why the multiply? Why that?
Why
Why the
multiply?
multiply? Because it's 2 options, right? 2 options. 2 options for second one.
No.
2 options for third one, right?
So it can belong, or it can have a same subset at the same time.
Yeah, so here's the thing. Here's why it's multiplied. It's because this can be 0 or 1. So if we considered it with 2, right? You could have 1, 1, 0, 1, 1, 0, 0, 0, right? It's like you have 4 options for 2, right? Because either 1 can be 1 or 0, right? So 2 options. Options, right? Okay?
Yes.
And then you have n numbers or n items, each with 2 options. Okay?
Yes.
So for everyone, it's like he wrote, the first one is 2 options, right? The second one is also 2 options.
Why can't we add them?
Because the second one it's different, because if the first one, say the first one is 1, right? Then the second one is 0, but that's different than if the first one is 0 and the second one is 0.
It's like coin toss.
Yeah, it's like a coin toss. Because if the first one is 1 and the second one is 0, the sequence is different. If you add, it would mean that these 2 are the same. Because there would be 2 options for the first and then 2 for the second, and you would add. But it needs to multiply because you need none of the others. You could have all 1s and then 1 0. And that's different than if any of the others were 0. Okay? It's like tossing a coin. Does anybody get it to multiply? Hey, everyone okay on the multiplying?
Yes.
Online, are they okay?
한번 더 설명해줘.
응?
한번 더 설명해줘.
한국어로, 한국말로.
한국말.
한번 해봐.
한국말로 y multiply.
네.
한국말로 잠깐만.
잠깐
오케이.
해봐.
우리말로 잠깐 설명을 해드릴게요. 이게 중학교 오면 확률이라는 걸 배우기는 하지만 자,
아니 하지 마. 좀 기억해서 나쁜 학생.
why
자만한.
자만.
arrogance.
다 알아들어.
그러면은 여기 n 수열을 생각해 봅시다. 자, 그런데 숫자가 안에 n 개가 있죠. 근데 1 아니면 0으로만 n 개가 있어야 돼요. 여기까지 이해가 됐죠. 그러면은 이게 또 1 아니면 0이잖아요. 근데 1하고 0이 옵션이 두 개라고, 이렇게 두 개의 옵션을 가지고 있어요. 그런데 여기서 왜 곱하냐면 한번 세 번째로 예시를 들어볼게요. 세 번째면은 뭐 만약에 숫자가 있으면은 요거가 있겠죠. 근데 각자 1 아니면 0이야. 그래서 여기 만약에 다 1을 넣을 수도 있고 다 0을 넣을 수도 있어요. 근데 이게 1, 0일 수 1, 0, 1일 수도 있고 1, 0, 0일 수도 있고 0, 0, 1일 수도 있단 말이야. 그리고 0, 1, 0일 수도 있고
근데 이거
this is the example. 자, 요건 아니에요. 이건 그냥 예시를 들기 위해서 한 거고. 그리고 뭐냐? 그리고
1,
0, 1일 수도 있고
1, 0.
1, 0. 자, 이렇게 여러 가지가 나올 수 있단 말이에요. 왜냐면은 0 아니면 1의 조합으로 겹치지 않게 이렇게 모두 다 만들 수 있어요. 그런데 이거를 세보니까 개수가 하나, 둘, 셋, 넷 하고 5, 6, 7, 8에서 총 8개죠. 그런데 이 결과가 공교롭게도 가능성 2개와 2개를 곱한 것과 같아요. 이것만 가지고 섣불리 할 수는 없겠지만은, 자, 이렇게 2개가 들어갈 수도 있고 2개가 들어갈 수 있고 2개가 들어갈 수 있으면은 이게 모든 거를 다 고려를 해야 되잖아요. 여기가 그러니까 각자 2개씩 들어갈 수 있고 2개씩 들어갈 수 있고 2개씩 들어갈 수 있고 각자 2개의 옵션이 있기 때문에 이렇게 곱해서 화를 내는 거예요. 그렇기 때문에 만약 여기 n개가 있다 그러면은 2를 n번만큼 곱하면 되겠죠. 그래서 2의 n제곱이라는 공식이 유도가 되는 겁니다. 네. Thank you.
Okay. So, is everyone clear on why
Yes.
on both problems? I know you are. All right. Oh no, are they making fun of you? If they're making no, he did so well. Don't make fun of him. If they're mean, I'm gonna punch. No.
So she asks, what is vice versa?
Vice versa.
That's like. It's like if you swap these. Everything in S maps to item in B. Everything in B maps to an item in S. So it's like X maps to Y and vice versa. That means, this means Y maps to X.
What means maps to?
Maps to, it's like
Connect?
yeah, it's like they can go from one to the other.
No.
What are you talking about?
He's twins. For twins.
For twin? Oh my god.
준이 leads to 준구 and vice versa.
No.
I mean, kind of. She seems very sad about it. It's okay, I'm embarrassed to be related to my brother too.
You're his younger brother?
No, he's older. He's a 나쁜 오빠.
Why
Yes.
not?
He's a bad boy.
He hit you?
No, not since like very little, but he's just mean, like in different way. Not physical, but he says mean things.
He teased you?
Not teasing, genuinely mean.
He said you to give some money.
No, he says like
She said she understands.
yay!
Alright.
Oh, because
Okay.
of me or not?
저
This
vice
is
versa.
same, right? Because
네.
in S, if it's in, we say in is the same as 1. In is the same as, is the same as 1. In is the same as 1. In 1. In 1. In 1. Alright, and then what we say is we say out 0. Out 0. Out 0. Out n times. Okay? Each one has n. Okay? So this is n, and this is n. And so we say that these two, S and B, have a bijection. Which means they're the same, basically. Same problem.
Hooray.
You sound so excited. Okay? Alright. So, let's go on to another problem.
I'm so tired.
You're so from teaching it. You're so nervous. Don't be nervous.
Do you think I did well?
Yes, very good. Very good.
Thank you.
Almost perfect.
Not exactly perfect.
Nothing is ever perfect.
Yes.
Nothing. So he did very good. Okay. Okay. This is a little hard.
No.
So, I just want us to try to think about it. Is that okay?
Yes.
Okay. So, consider a sequence of n such that A, hold on, I need to get this right, equals A1, A2, A3, up to AK, so there's K, right, of positive integers and the sum of AI over I equals,
I
N.
is 1.
huh?
I can be 1.
Yeah, so it's just whatever, it's just like some sequence of numbers that add to n. Okay? So some sequence, so like if n equals 3, you could write 3 equals 1 plus 2. Okay?
Yeah.
N equals 5. You could say 5 equals 1 plus 4 equals 2 plus 3 equals, no you can't.
4 plus 1. The same?
Yeah, we did 1 plus 4. 1 plus 4 and 4 plus 1 is the same, right? Yeah.
0 plus 5.
Huh?
0 plus 5.
No, because positive.
0 is not positive.
No, 0 is non-negative, but it's not positive. Okay?
It's weird number.
Weird number. Yes. Okay. So I'm claiming I want you to try to find the number of sequences A for a given n.
Given.
So that just means if I gave you a random n, I want you to find the number of sequences you can make. And my hint is to look at how do I do this? Wait, I think this is also, because you can also write this as like 1 plus 2 plus 2. Yeah.
1 plus 1 plus 1.
1 plus 1 plus 1 plus 1 plus 1.
Oh. 1
Uh,
plus 1 plus 1
yeah,
plus 2.
yeah, yeah, and then this can be 2, you know, 1 plus 1 plus 1
1
plus
plus
3, yeah, yeah, so,
Oh, 1 season. How terrible.
okay. So, I want you to think about this, just to try to, let's try to notice a pattern, okay? Equals, I'm not sure, wait, let me look at the specific, because I feel like it might be different if you reverse it based on the answer. I think that it's different.
So
I think, that's strange.
that's John.
I think it's,
Oh,
I think this is different. Yeah,
oh.
yeah, okay. So, let's try to think this through. Alright? Alright, so, let's write this neatly.
Yeah.
First, n equals 1,
Equals
okay?
1.
Okay, so then we have just 1.
1 is 1.
Yeah, there's 1. n equals 2. We have
2.
1 plus
1.
1.
Yeah.
And then we have 2.
Hmm?
2 itself. 2 sums to 2.
Oh,
Okay? n equals 3. Okay?
3. Yeah. 1
So-
plus 2.
1 plus 2. 2 plus 1.
1 plus 1 plus
1 plus 1 plus 1. 3.
3.
n equals 4. Alright, so how many are there here?
1.
1.
1.
2.
Okay, 2.
2.
4.
4.
Okay.
8.
I don't know. I don't know. What do you think? Let's go. Let's try it. Alright?
Yeah.
So we have, what do we have first? 2 plus 2. 1 plus 3. 3 plus 1. 1 plus
1 plus 2.
1 plus 2. 1 plus 2 plus 1. 1 plus, or 2 plus 1 plus 1 and did we miss anything? Yeah, 1 plus 1 plus 1 plus 1 and 4. How many is that?
8.
Huh, interesting.
Two to the n.
What?
응?
N is 2.
2n?
And
What is the answer?
2 to the n.
No, because 2 to the 1 is 2. 2 to the 2 is 4.
2 to the n minus 1.
응.
Okay. So, now let's try to think about why.
Right. Because all we know.
No, so we have an answer, okay?
Yes.
It's a little hard. We have an answer. We want to think of another problem that we want to, like if we find the answer to this other problem, we can get this. And I'm going to give you a little bit of a hint. Have you ever seen, like, you know choose?
Choose? Chupa choose.
Okay. Have you ever seen this triangle?
Pascal?
Yes.
3,
3.
3,
1.
Okay. Yeah. And then what's next?
1,
4.
4,
6,
6,
4.
4, 1.
6.
This pyramid.
Yeah. So this is actually, there's an interesting bijection between this and choose.
Choose.
Like the and choose K thing. Like okay. So let's think about this.
The sum of this is same.
Well, I'm not sure. Is it?
Yes.
Why?
I'm going to prove.
Okay. So let's think about this. How many ways can we split a number into basically different numbers?
Split?
Sums, right? So we want to look at the sum of something, right? So when we look at the sum of, for 4, you know, how many ways can we write it, right? So, okay. So, what's the maximum number of items in A? A max. The maximum number of things we can have.
K.
So yeah, what's K equal to? K maximum, right, is equal to what?
K maximum
The most number.
is
How many? Because it's what's the most? Here's the most for this one. For 4, here's the most items. Here's the most for 3. Most for 2.
K. Most is K.
N?
How many? Yeah, N. Right? So that's the biggest, because it's just 1. When you have 1 plus 1 plus 1 plus 1, you have N ones.
Yes.
What's K minimum?
1
Yeah.
itself.
1. It's just itself. Alright. And then you have things in between that.
A discussion?
Well, let's think about it, okay? So we're trying to think about why this is 2 to the n minus 1, right? So the most items you can have in the set is n, and they're all 1. All 1s, right?
Yes.
What's this one? 1, and it's just it's equal to n, right? 1n. What about if you have an n minus 1?
What?
Okay. So I want you to think about like how does this one relate to this? Right? Because for 2, we have an option. We have the n minus 1 plus 1 or itself. Right? Alright, what's this? This is n minus 1 plus n minus 2. N minus 2 plus n minus 1. N minus 1 plus n minus 1 plus n minus 1. N minus 2 plus n minus 2 plus n minus 2. And then n. It's all combinations of previous. Yeah, we don't have to solve it. It's just, I just want you guys to start thinking about this. And that's how many ways you can arrange it. Okay, this might be a little hard. I think I will give you a puzzle instead. But this is a good problem for like. Okay, well, there's also another thing I wanted to try, which was I'm gonna give you know dominoes?
Domino.
Yeah, what does a domino look like? Right? It looks something like this.
This is a Chinese letter.
I know, it means like day,
Yes. How
Yeah.
do you know?
sun.
How
Yeah.
do you know?
Because I know Japanese, not as well as Korean, but sun.
Japanese?
I also learned Japanese in school.
Oh, so good.
Oh,
Oh.
You're still language.
これは日。he.
he?
he.
Not professional.
He's beginner.
So he's very beginner.
Yes.
Okay. So this is like some domino, right?
Yes.
Okay. Now it's a domino. It's not a Japanese or a Chinese letter. Or a Hansa, whatever. Okay. So we have a letter, right? I'm also tired. Alright, we have a domino.
Yes.
Alright. I'm saying that this dimension, like this, is n, such that, it's like, this is 1, 2, and then this is, n minus 1, n. And I want to say how many ways can you fill the board? This is the board, the game board, with
Domino.
dominoes.
There is only one domino.
No, it's I think it's, well, how many dominoes would you need to fill the board?
N.
Well, yeah, because it's n by 2, 2 times n, so n dominoes, right?
2 times N.
Because this board, the area is 2 times n, right? Because this is 2 and n. So for example, for 1, right? This is 1, this is 2, 1, and then you put 1 domino. 1 domino. And then for the 2 by 2 case, n equals 2.
G domino.
No. Because the domino can go, like, the 2 dominoes can go this way, right?
Yeah.
But you can also put the domino like this, okay?
two way.
So
this,
in this case, how many ways are there? Yes.
this or this.
Yeah, like that.
Oh.
But then it gets more complicated when you go bigger.
Oh.
And I want you to try to do that.
I hate domino.
You like dominoes.
Domino pizza. Do you know Domino Pizza?
Yes,
Brand.
of course. It's from America.
Oh, really?
Yeah,
Oh, I also like Papa John's.
that's also from America. Korean pizza is interesting.
Yes.
There's some actually. I think like there's some places. That are, I don't know. I think they just put so much meat. You got pizza. They put so much pepperoni on it. They're like, let's put so much pepperoni.
I guess my brother liked that.
It's interesting. And then it's like spicier than American. It's not spicy, but it's like spicier. They like that. So let's look at 3 by 3, 3 by 2, right? So 2 by 3. This is not good. Too big. Here we go. Okay. Alright, so how can we fill this with our dominoes? What's one option? Here's the easy one, right? Right, you've got 3. 1, 2, 3, right? Alright, what's another option for us?
1, 2, 3.
1, 2, 3,
Yes.
and?
1, 2, 3.
You mean this way, right?
Yes, I meant this way.
Yes, any more?
No.
No. Okay, so we got 3, 2, 1. Alright, that's interesting. So far it's equal to 10. Okay? Let's do 4.
Roll. How complicated.
It's not that bad. You guys can do this one. I switched to this one because it's easier. It's a cool problem, this one. The answer is cool. When you get it.
Cool.
Oh my god, you guys have the life stamped out of you by school already. I was the same. In my freshman and sophomore year at MIT.
You freshman?
No, when I was. I'm a senior.
Ah.
I'm almost done. Thank God.
Senior is 3rd grade? Oh.
That's the only reason I can smile is because I'm a senior. If I was a freshman, I was
Freshman depressed?
yeah, sophomore is the worst. Sophomore is the worst.
Oh.
Second year is the worst because it's not introduction classes anymore.
In also Korea, there is a 중이병.
Oh,
You know what this is?
it's like an illness.
Not 병, but 중이병 means the 2nd grade of middle school in Korea. So they are very their mind changes a lot, and they are very tired in mentally, so they disobey and they 일탈 행동. So that is 중이병.
So 2, you would just go this way. Alright, so that's 2. What are the other options? Well, you can have this.
This.
So that's
1,
1.
2, 3, 4.
And then the other way.
Yeah.
2, 3, yeah.
Anything else?
And 1, 1.
We did it.
I don't think so.
네.
아.
그래 조금만.
네. don't do it. Alright, let's try one more. We gotta keep going. Come on, this is how you do it. You gotta just keep looking at them. Alright, let's go to 5.
Let's go to home.
Why are you guys so sassy today? Do you know what sassy?
Sassy? Overall,
Sassy, you know what it means?
Oh yes, we don't
It's
know.
like you say things that are kind of like
Weird.
talking back to me, it's like little bit rude, but not so rude that it's like it's rude but funny. Rude but funny, you know, sassy, like, oh, let's go to the next one. Let's go home. It's like this kind of feeling, like that kind of face, you know, like, yeah. Okay. Sassy, important.
Okay, we got one more.
Okay, let's try this. There's this one.
Yeah.
1. Okay. What about anything else? Well, notice that this is number 4.
Yeah. Yes.
And can anything else go here?
No.
No. So how many ways can we do this with this one?
5.
Yeah.
It's you. 5.
Yeah. Okay, that's 5, and then what about this one? Oh no, I don't think so, because some of those are the same. But okay, so there's 4, right? So it's 5. Now you gotta figure out how many that you're gonna double count. So you've done everything with this domino this way. So now what does that mean? It means this has to be facing this way, right? Come on guys, come on. Count them, okay? So you've done everything with this domino like this. And that's 5. What does that mean?
Others are also 5.
That means you have to put it this way. Right? Okay, so I've got the domino this way, and then I have the 4, right?
Yes.
Yeah, this is 5 ways.
Yeah.
I've done everything with this domino facing that way. So what does that mean? All possible options. So it means that we have to lay it this way. Right? So can I do any more? If I've counted 5 of this, can I do any more with this one facing up? No. Okay, so what do we have to do? We have to put it this way. Right? So here's our 5. Right? Okay. So here's our 5. Okay. And we can't put the first domino here, this upright, right? So what we have to do is we have to put it like this. Right? And what does that mean about this? What does that mean about the one above it? Yeah, it also has to go like this. Because there's no way to put that one upright either. Alright, what do I have here? These two have to be like this. What's here? What's here?
Rare.
Okay, so we've decided these two need to be like this.
Yeah.
I want you to look at what you have right here. How can we arrange this? How many ways? What does that look like?
3.
3. Yeah, how many ways could we do that?
6. 3 times 2 times 3.
No, 1, 2, 3.
Yeah.
1, 2, 3.
Yeah.
1, 2, 3.
Yeah.
3 ways. Okay. everything with those two. Is there anything else we can do?
No.
Why? Why are there no more ways? Why is 8 the number? Can we check? I want you to check that there's 8 ways to arrange the dominoes. Who have I? Alright, so I'm saying that with the 5 by 5, there's 8 possible arrangements of dominoes. Okay? So, the first thing we do is we put the first one here. There is a domino here, okay?
Yes.
And then we have, what do we have left over?
There's an 8-way.
Alright, try to place the dominoes. We placed one there.
Yes.
Try to place them in the 4 by 2. Yeah. Why? Because, okay, here's one. There's one.
Mm.
There's one.
Mm.
Alright, what else can I do?
Yes. And reverse.
And? Yeah.
Mm.
Sorry. This way and this way.
Yeah.
Okay. 5.
Yeah.
That's with this one facing this way. Alright. Now let's change it. Let's change where the first domino went. Here's case number 2. Let's have first domino goes here. Sideways.
Oh, that's very tricky.
Okay. Well, it can't go this way because we counted everything else. So it has to go a different way. So let's just put it sideways. Alright, what's true about this one? What's true about above this? It has to go this way.
Yeah.
Alright. Now, let's see.
The 3.
Yeah, so these are all going to be different from those, right?
Yeah.
Right, because this one is sideways. And this is the 3 by 3. So let's count. Here's 1. Here's 2. And here's 3. Okay. Now, why is that it? Are there any more arrangements for a 5 by 5?
No.
Why?
Consider all the possible.
Yeah. Okay, so it's 8, right? What about a 6 by 6? Let's go one more.
4.
Alright, so let's look at the 6 by 6 case. Yeah?
Can I look at that?
Yeah.
She said, can I go to bedroom?
No.
Everyone is so tired.
6 and 7, 8.
Alright, try to count for 6.
We can get the answer like that way.
I would recommend doing it that way because it's going to be interesting. Because I want you to think about it as each time you add 1 extra here.
Yeah.
Alright? It's just, this is the only difference. Between 5 and 4, this is the only difference. Okay? And I want you to think about what that means. So solve for 6 and then let's go back to 1 and see how it's happening. Yeah. So,
Yes.
the only difference between this one and that one, in 5 and 6, is you add one 2 by 1 column. Okay? Just one, alright?
Is there a certain way to?
Let's first see, okay, so let's find 6 and then we'll report our findings. So the first one, 1 was 1.
Yeah.
What was 2?
2
Yeah. 2,
and 3
3,
and 5
and,
5 and 8.
okay.
말하는 거야?
I want you to find
이게
what?
한 개,
아니,
세 개.
first one and third one is 1 plus 2 and fourth one is 2 plus
Okay,
3.
try 6. Find 6 first.
Okay.
Then we see. And then we'll see why. But yeah, we're starting to notice a pattern. But we want to see if it's right and why it would be right.
Is 5.
Okay. Alright, so let's draw 4. Okay. So, let's count the number of ways we can place the dominoes. Alright, so, let's put the first domino here. Okay? That's where the first one went. Okay. We can do this. One here,
Yes.
one here, one here. There's one. There's another one. Okay, here's a second, here's another one. Oh god, it's a stupid safety alert. Okay, here's one. Okay, and then we have one here, one here, one here.
Yes.
Alright. And then here's one. Alright, one more. Right?
Yes.
What's the last one? We can have them all facing up. Alright. There's 3. Okay. Now, we've done everything, right? Like, we've done everything with this domino here. So what do we do now? We put this domino facing this way, the first one. What does that mean about the second one? Goes here, yeah. And then what can we do with this? Let's do it this way, yeah. Alright, and then one more. Let's try this again. We put this one here, this one here, and then we can put these 2 sideways. 5. Alright, so, has anyone gotten the answer for 6?
13.
Oh, okay. Why is it 13? Please explain.
It is 6,
Mm.
and there is a 5,
Yep.
and the 5 is 8,
Mm.
and so it's 8. It is fixed, is no matter.
Yep.
And it is fixed, and it can't be that one. So it is fixed 2.
Yeah.
And there is 4 times 2 block. So it is 4 is 5, so it's 5.
And why can't there be any more? Why can't there be any more? Alright. So what I want us to look at is I'm gonna erase this. I want us to look at the progression. Okay? So okay. So alright. So we're gonna start with 1. Okay? And I'm gonna draw it over here because we're gonna build off of this. So with our 1, we just have 1 domino. Put the domino here. Right? So there's 1. Okay. Now to make 2, what I do is I draw another. Now, I want us to put the first domino here. Okay? And then what's remaining here?
1.
1. So, how many ways is that?
1.
Yeah. So 1 was 1. 2, we have 1 plus.
1.
Now, because we have this new little thing here, what can we do? What does that mean? What do we have now? Yeah, now we can also place the first domino like this. Alright? And then what about the second one? Yeah. And there's no more, because we can't place the first domino anywhere else. Okay. Now, to get to 3 from 2, what are we doing? We draw this. Alright. What am I going to do first? Where does the first domino go?
Face off.
Yeah, we're going to put him here. Because then, what is this? This is the 2 case.
Yes.
So, we have, that's 2 ways, so 3 is 2 plus, the only thing that's new is this part, okay? So, what can we also put? We can also put the domino here, that's new, right? Okay? And then, what about the next one?
The 1 case.
And then we have a 1. Ah. Right, okay. Well, and what if we put the first domino here? Why does that not help us?
Oh, it is same. It's facing.
It's not new. Not new, right? It's the same, it's accounted for in the 1, which accounted for this, and the 2, which got this part. Okay? Alright, let's go to 4. What happens here? Alright, yeah, so we put our first domino here. This is the new part. This is the old part. What do we get here?
3 case.
3 case, yeah. Which was 3 ways. So we have 4, 3 plus. Now we have another option with our new squares. So these are new, right? And our new option is to put the domino, our next option is put it that way. This one has to go here. And then what happens here? I mean, sorry, what happens this part?
2 case.
2 case. Huh. Yes. Sorry. Interesting. Alright, let's do one more. Okay? Alright, so this is all old now. Old. And here is our new stuff. New. Okay, let's put the domino here. What do we have here? This, all of this?
4 case.
4 case. Interesting. Okay. Well, we also can put, because this square is new, we can also put it like this. And this. And then what do we have here?
3 case.
3 case. And everything else is old, which means we've already counted it. Okay? So, 5, we have the 4 case plus the 3 case, which is, alright, 4 case was 5 plus 3 equals 8. Alright, so if we were to write this as a recurrence, we would say let t of n be the number of ways to cover the board with n dominoes, right? Okay. So we would write t of 1 equals 1, t of 2 equals 2, and what about t of n? Yes. So if I have a board of size n, alright, so let's go to my board of size n, okay? Alright, so here's my 1, here's my 2, here's my n minus 1, n minus 2, right? Okay, right? Alright, so what do I do with my first domino? I put it here, right?
Yeah.
What's left for me?
n minus 1.
N minus 1 case, which is t of what?
Q of n minus 1.
Yeah, the number of ways for n minus 1. Alright, but since this square is new, what else can I do? Sideways, yeah. Okay? Okay, right? So, and then what do I have left?
N minus 2.
The n minus 2 case. And nothing else is new, right? There's no other way to place a domino in a new square, right? Alright, so what is that equal to, the n minus 2 case? T of?
N minus 2.
Alright, and I want to know T of n, what is that equal to?
Q of n is T of n minus 1 plus n minus 2.
Yeah, T of n minus 2. And does this look familiar? Does this recurrence look familiar to some sequence of numbers that you know? Well, let me start writing them.
Fibonacci number?
Yeah. Right? Yeah. This is the recurrence for the Fibonacci numbers. Interesting, right? Alright, now I want us to think about how we might prove this bijection.
Oh.
How can we prove that? We have defined T of n here. T of n is the number of ways to cover the board with n dominoes. P of n equals n Fibonacci number. For n greater than or equal, for n, well, I guess n minus first Fibonacci number, sorry. Because the Fibonacci's are 1, 1, 2, 3, and ours are 1, 2, and this is the second one, 3, etc., right? So ours is the n minus first Fibonacci number. Alright, how are you going to do that?
Bijection.
No! How are you going to do this? That's the bijection, is that we want to say that this is the nth Fibonacci number. But now we have to prove that they're the same thing. How are we going to do that? Yeah. On what?